Hello guys, here Mr. G with another video. This time is for the grade 10 because the question papers are going to be as well written now. But before we carry on, please subscribe for the channel so you can get the notification and all the videos I post on regular basis. This question was done in the Northern Cape in 2013 and it was one of the June examination. It's a good question paper. Question said, water waves collide with a harbor wall as indicated in the diagram below. 9 waves hit the wall in 12 seconds. The distance between two consecutive troughs is 3 meters. The height of the wall of the wave from the trough to the crest is 7 meters, and there is the picture, guys. How many waves are indicated in the diagram above there? In the diagram, how many waves are represented there? So if we mark here, starting from A, we have one wave when the water goes from A to this point. There is one wave there, as from there is coming to another complete wave when the water goes up until this point. So those are 2 waves, and then from there you can see it's going all the way up until here, so that is half a wave. If it was complete wave, it will go all the way there. So it is 2. How many waves are indicated in the above diagram? There is 2,5 waves. 2,5 waves. Write down the letter which represent a crest. Remember, the crests are the highest points there. So the crests are those points here, either B, D, or F. So in this case, you can write any letter between B, D, or even F. Any of those will represent a crest. Now the second one, 2.2, a trough. The trough, remember, is any point that is at the bottom. So all those points here are going to be trough, which in this case is only 2, so it can be either a C or E. Either of those will represent a trough. One complete wavelength. Now, one complete wavelength is the distance between two consecutive points that are in phase. In this case, it's also 2 consecutive trough or 2 consecutive crests. So, in other words, 2 points that represent a wavelength here are either the distance between B and D. For example, this distance here between B and D can represent a wavelength. That distance there is one wavelength. Remember, the symbol for wavelengths is lambda. Or D to F, this one here represents another wavelength, which is the same distance. Or could even be the distance between C and E. The distance there is also a wavelength. And now, by the way, if you look here, you can see that the wavelength is going to be equal to 3 meters. This one is for a little bit later on, but we're going to mark it there. So the letters that represent a wavelength, you can, guys, say either B, D, or you can say DF as it is there up, or you can say, or you can say CE. Any of those will represent a wavelength. 2 consecutive points in phase. And remember, points in phase are points that have the same motion at the same time. Guys, this one is going to be very much the same as the wavelength, because remember, the wavelength is the distance between 2 consecutive points that are in phase. So 2 consecutive points in phase could either be B and D, or could be D and F, or could even be C and E. Those are points that are in phase. And 2 consecutive points that are out of phase. Now be careful, because I say consecutive points that are out of phase. Now here, points out of phase that are consecutive, there are too many. So for instance, B here is a point that is out of phase, and the consecutive one will be C. E is also out of phase with B, but C is the consecutive one. So you can say, for example, B and C, or for example, C and D is also consecutive point out of phase. C and D, and another points out of phase that are consecutive are D and E, because C and F, for instance, B and E, but they say consecutive one. So D and E is another one. And guys, E and F, but I'm not going to write that one as well. E and F is also points out of phase that are the consecutive one. Determine the magnitude with the correct unit of the following for the above wavelength, and we already spoke about wavelengths, guys. We already even marked there is 3 meters there. So this one is 3 meters. Okay, the amplitude, remember the amplitude is the distance between the position of rest. Now the position of rest in this graph is not indicated, but the position of rest will be right in the middle. So this one here that I am marking now here will represent the position of rest. This one is rest position. This one is rest position at that point. So the amplitude is the distance from from the position of rest to the crest. This one represents the amplitude, with 1A I'm going to represent it, or from there to a trough. That one is the position at the amplitude. Now guys, we don't have the distance, we have the total one, which is 7. So therefore that one will be half, which in other words is 3,5. So the amplitude is 3,5. They say correct unit, be careful, we must go back there, it's in meters, so it's 3,5 meters. Now frequency is how many waves pass a point in 1 second. Now if we read the question say exactly that 9 waves hit the wall in 12 seconds. You go here, 9 waves hit the wall in 12 seconds, guys, but we don't need 9 waves, we need how many waves are in 1 second. So we are coming here and we're going to do it using that cross product I showed you long time ago. So you come and you say 9 waves takes 12 seconds, but I don't want to know that. I want to know 1 second how many waves will pass, and I make that one the unknown. Then I come here and I do the cross product, guys. It's very simple, cross product there, and when you do that you get that x is equal to 9 divided by 12. You must do it properly, and this one will give you 0.75 waves. 0.75 wave there. So the frequency then is going to be 0.75 hertz. Remember the unit for frequency is hertz. Now calculate the period of the wave. Now if you have the frequency, the period is quite simple. Period is equal to 1 divided by frequency, and you do have the frequency, so it's 1 divided by 0.75, and then when you calculate that one will give you the period. So the period is going to be equal to 1.33 seconds. Remember, is the time for one wave. This is an option of doing it, it's not the only one. So the period here is equal to 1.33 seconds, guys. We almost done. The speed, you have to calculate the speed. There are a few questions of calculating speed. I am going to use only one of the formulas, but before doing that I wanted to show you that in the exams, at the back of the exam, guys, here are the formulas. These are the formula for speed, as you can see here. There is the formula for period, as well as there is the formula for speed here. So all the formulas are there. If you rearrange, you have formulas now for frequency as well. Okay, so there is all the formulas that we are going to use. So we're going back to the test. This is a good test, 2013. The whole question, here we are. So speed is going to be equal to frequency multiplied by wavelength. And you do have both of them, guys. So the frequency is 0.75 and the wavelength is equal to 3. So when you multiply that one, you get that the answer is 2.25 meters per second. So this one is the speed of the wave, 2.25 meters per second. But guys, this is the answer, the answer of the question, as well as the final question of this video. Thank you for watching. I hope it helped. I hope you do well in the exams. I'll see you next time. Mr. G here.